Hello, this is Professor Brian Hutchison with Victoria College, and we are going to do Exponent Rules Part 2. So we left off with things raised to the zero power, which is new to a lot of people. But what about a negative exponent? Right? What if I had, let's do a to the negative 2. What does that mean, right? Well, I'm going to tell you that you have all the tools necessary to figure it out, but let's just play around. And once again, it's Quotient Rule that usually helps us see this guy. So what if I had a cubed divided by a to the 5th? Well, the quotient rule would tell me that this becomes a 3 minus 5, which is a to the negative 2 power. So congratulations, this is where a to the negative 2 kind of comes from, but still that doesn't help me know what a to the negative 2 power is. Well, if we use our definitions of exponents, that's times an a times another a. So a times itself 3 times over a times itself 5 times. And look what happens, folks. On top I get left with a 1, and what's on the bottom? A squared. Oh, a to the negative 2 is nothing but 1 over a squared. What does that tell you? This is a hard one. Some more advanced properties of exponent rules. So it doesn't necessarily, a negative exponent doesn't mean you're going to get a negative answer. It is just its placement. It is just its placement. So if we see, so just some examples, if you see x to the negative 5th, right? I call it keep or move, right? This thing is telling me that I need to now move it into the denominator, right? Because it's a negative 5 power. Well, this becomes 1 over x to the 5th. Well, what happens if I had something like 3 over, let's do a b to a negative 2 power. Right? Totally separate problem. We usually say we don't want to leave things with negative exponents. We're still just simplifying. Right? We don't want to leave the negative exponents. Well, b to the negative 2 power is actually in the denominator, which means I'm going to move it to the numerator. But does that negative 2 power have anything to do with the 3? The answer is no. This guy will just become 3b squared. I keep the 3, I move the b to the negative 2. Let's keep going. What if I had 2x to the negative 5th power? Good time to pause it, try it on your own. I just want to warn you though, does the negative 5 influence the 2 at all? And the answer is no. So I keep the 2. I'm going to move the x to the negative 5th. Technically it's in the numerator, everything's over 1. So I move it down to the denominator. What if I gave you 2x to the negative fifth power, and I put the 2x in parentheses? Is the negative exponent actually messing with the 2? The answer is yes. This one's different. Here, the 2x would be pushed to the denominator, and the negative 5 becomes a positive 5. We could then use power rule, which says this is 2 to the 5th and x to the 5th. 2, 4, 8, 16, 32. So fully simplified, this becomes 1 over 32x to the 5th. All thanks to that parentheses. So you got to be wary of those parentheses. They always want to come back and bite us, right? I only believe that there are 25 letters to the alphabet because I don't know why. That's a joke, get it? Don't know why? So that'd be 25? Never mind. How y'all feeling? This is only half of the negative exponent rule. It gets even cuter. So what's happening, folks, is, so the rule really does say that anytime you see this raised to the negative 1 power, we do 1 over x. And that x is to the first power also. Well, how does that relate if I had to do x to the negative 2? Well, it's just the power rule. This guy is x to the negative 1 quantity squared. Remember, negative 1 times 2? Which then tells me what? This is 1 over x quantity squared. When you square the 1 to get 1, and you square the x to get your x squared. But isn't it easier just to play keep or move it? I'm going to tell you what the most common mistake is. Things like this. You drag the 2 along with it. Or this one with the 3. Right? You flip the 3 to the bottom. The 3 never had the negative exponent. So before we do an example, a true blue, all-out example, I've got one more of these exponent rules, how they say, is if you ever see something a little more complicated with parentheses around it raised to a negative something power, well, you don't even have to play keep or move it. All right, that negative 1 is now going to influence everything. Well, if the negative 1 goes to everything, what happens to the stuff in the numerator? It goes to the denominator. The stuff in the denominator goes to a numerator. I call this guy the flip. Right? Because that's its job. So the intimidator. Just checking my time. We're good on time. What if we had 2 x squared y to the negative 3 z to the 5th over 4 x cubed y cubed and z to the 7th. And I'm going to take this whole thing, I didn't need my line to be that long, but I'm going to raise it to the negative 2 power. Well, it's PEMDAS all over again. So we look at our parentheses. Is there anything in the numerator that we can tackle? Well, I have a 2, I have an x, a y, and a z. There's nothing I can mess with. Then you look in the denominator and you have a 4, an x, a y, and a z, and there's nothing I can mess with. And then you start to say, well, shoot, I have to simplify then. Well, don't let this guy mess with you. 2 over 4 becomes what? 1 over 2. Because I can erase the 4 and literally put 2 times 2 and do the cancel out maneuver. So now here's where our paths kind of diverge. If you want to use quotient rule, you can now use quotient rule on your x's. But if you do 2 minus 3, you get a negative 1, right? I usually like to see it as the cancel out method. You have 2 x's on top, you have 3 x's on bottom, right? An I for an I, they're going to cancel each other out and they're going to leave x where? Oh, on the bottom. Well, but that is x to the negative 1, right? 2 minus 3 is a negative 1 and we're going to move it to the bottom. So now we look at our y's, and you can use quotient rule here, but I would highly suggest play keep or move it. When we do adding and subtracting with negative numbers, things usually get a little confusing. All right. I'm going to keep my y cubed on bottom, but I'm going to take this guy and move it to the bottom, and I'm going like, oh yeah, that's product rule. We just add them together. And then we do the same thing with our z's. The z's are bigger on the bottom. So you have 5 on top, 7 on the bottom. You're going to get left with 2. But 5 minus 7 is a negative 2. Then you do your negative exponent rule and pushes it to the bottom. But this is cuter. So the whole point of this thing was really to deal with that negative 2 on the outside, but what does the negative do? All the negative does is flip it, right? Remember, if it's on the outside, this guy really just means flip. Well, you're going to get a 2x y to the 6z squared over 1. Do we really care about being divisible by 1? No. And then we square it. Well, what's 2 squared? 4. What is x to the first power squared? Well, 1 times 2 is 2. This is just which rule? This is the power rule. Y to the 6 squared? Well, 6 times 2 is 12. And z squared squared? Well, 2 times 2 is 4. That's my final answer. All the negative on the outside exponent did was flip it. But I could have just brought in a negative 2 and then did each one, but it's more efficient just to see that guy as the flip, if it's outside the parentheses.